सर हमने वो उधर तक किया था जिधर वो दो एक्सरसाइज के लिए एग्जांपल्स थी।
खास तौर पे ये मोमेंट्स एंड मोमेंट रेशो ये कर लिया था। एक तो ये असाइनमेंट भी आप लोगों के जिम्मे है। ये आपके सेक्शन ने कंप्लीट कर ली है। And this one is at last page. अच्छा
सर वो एक्चुअली लास्ट वीक में लेक्चर भी नहीं था हुआ और उससे जो पहला वीक था उसमें भी आधा लेक्चर हुआ था, इस वजह से हम पीछे हैं।
अच्छा ठीक है। So we have to start from here. The topic of moments and moment ratio. This will include skewness and kurtosis.
सर ये मेथड अभी हमने शायद कंप्लीट नहीं थे किए, स्क्यूनेस और कर्टोसिस वाले।
नहीं ये नहीं अभी हुआ, इसी में आ जाएगा। स्क्यूनेस एंड कर्टोसिस इसी में है। Okay, we have to study moments and moment ratio. The application is of these moments are again the analysis of data, particularly skewness and kurtosis. We use moment ratios to find skewness and kurtosis, and also it helps to find the basic parameters. And moments are of three types. First one, moments about the mean. Secondly, moments about origin. And the moments about any value arbitrarily chosen, that is called arbitrary mean, or you can say about a value A. What we do in these moments, we find the average of the powers, certain powers of the deviations, as this one showing exactly the definition of the variance. Mean of the squares of the deviations from mean value. So what is first? That is the mean of the power 1 of the deviations from mean value. And this one, we take the average of the cubes of the deviations. Here we are taking the power 3 of the deviations from mean value. Fourth one, here the power is 4 of the deviation from the mean value. We sum up all these powers and dividing by n. In this way, we get the mean value of the power 4 of the deviations from mean value. At the moment, we are considering only first 4 moments. That's all enough for the analysis. Similarly, if we have group data, we just multiply these powers with the corresponding frequency, again sum up and dividing by total frequency. In this case, in second case, that is exactly the definition of the variance. All the skewers are multiplied with the corresponding frequencies, and then we add and dividing by total frequency. Similarly, the other powers. And these moments are also called central moments. Central moments. Then we have first 4 moments about the origin, or you can say about x equal to 0. Also called about origin. In this case, we consider the deviations from 0 in all the 4 cases. Here we are taking power 1 of the deviations, but deviations are taken from 0. In this case, the deviations are taken from 0, square them and dividing by n. As subtraction from 0 is meaningless, so just we have sigma x over n in this case. And for second moment, we just have sigma x square over n. And third moment about origin becomes sigma x cube divided by n. And fourth one, sigma x power 4 divided by n. So in this case, quickly we have the definition of the variance, but with this relation. The relation of first 2 moments about origin. How we relate them? M2 prime minus square of M1 prime. So again, we have the definition of the variance. This one is the definition, exactly the definition of the variance, but this one is an alternative formula. And also look at the first moment about origin. That is just the definition of the mean value. Sigma x over n, that is the mean value. And now the first 4 moments about a value a. In this case, the deviations are taken from a value a. value A is arbitrarily chosen, but usually we consider within the range of our data. A is chosen within the range of our data to get better results. Okay, now as one of the relation we have discussed here, just like this one, as we know that a second moment about mean is denoted by M2, that is the variance, and on the right hand side we have moments about origin. So in this way we have expressed the second moment about mean in terms of the moments about origin. We have expressed here second moment about mean in terms of the moments about origin. Similarly, we can also express the other moments about mean in terms of origin. Here we have these relations. This one, this we have discussed. And third moment about mean in terms of the moments about origin. Similarly, fourth moment about mean in terms of the moments about origin. We can also verify these relations, but if you remember, that's good. M3. M3 by definition we know M3 is by definition within okay. Now we need to expand this cube. We can express it as by taking 1 over n outside and rest of the expressions are only sigma xi minus x bar cube. Now quickly expand this cube. We have sigma outside, sigma and 1 over n outside, xi cube, three xi x bar, xi square x bar. Our next term is 3xi x bar square. Our last term is x bar cube. Now apply sigma to all the terms and dividing by n. We have now let me multiply each term with this factor. We need to sum up, we need to apply sigma and dividing by n. This one and also this one. 3 is constant, so 3 comes outside and rest of the expression is added without x bar. Remember, this one is again constant. We can also take this x bar outside the expression, outside the sigma. This is not necessary, just for the convenience. 3 and x bar are taken outside and rest of the expression, because variable is there, variable term is xi square. So sigma is applied to only the variable terms. Again, in this case, x bar square is constant, so we take it outside and we apply sigma to rest of the term and dividing by n. And similarly, as here in the last term, we have only a constant. So a constant is added dividing by n. And we know when a constant is added, it becomes n time. And dividing by n, only we have x bar cube at the end. If we look at these terms, this first expression is, by definition, third moment about origin, denoted by M3 bar. This first term will be replaced with M3 bar. Look at here, we also know that x bar is our first moment about origin. Express it as M1 bar. And this expression 1 over n sigma xi square is exactly the second moment about origin. With M1 prime. M1 prime, this one, M2 prime, this one, M3 prime. In our third term, obviously, x bar is our first moment about origin and its square. And rest of the expression is our first moment about origin. So replace with M1 prime. And last one, what is this? When a constant is summed up, as sigma is applied to a constant, it becomes n time. So replace sigma with n. N is cancelled. We only have x bar cube. And what is x bar cube? X bar is actually our first one. So replace it with M1 prime. with power 3. And cancel. So expression. Our second last term is also m1 prime cube. This second last term is also m1 prime cube. So simplify last two terms. Simplify last two terms. We have this. So finally, simplifying last two terms, we have 2m1 prime cube. This expression. Just for convenience, shift this on the right hand side. So this is exactly the relation which we have here in this case. Here we must have power 3. Similarly, the other relations we can also prove, we can verify. Why first moment about mean is 0? Why first moment about mean is 0? The reason is that is the sum of the deviations from mean value is always 0. Or we can say this sum is 0 because in definition of first moment about mean, we have the deviations with respect to mean with powers of 1 and dividing by n. But in the numerator, this sum is always 0. Look at the definition. We have this definition of the first moment about mean. Due to numerator, it is 0. What we have in the numerator, the sum of the deviations from mean value. If we neglect power 1, that is meaningless. Just we have the sum of the deviations from mean value. And due to this strong property of arithmetic mean, we have this numerator 0. Directly you can say that sigma xi minus x bar is 0. Always it is 0. That's why remember first moment about mean is 0. Always in all the cases. Now we have an example in which first three moments about a value 2 are given. That's mean these first three moments about the value 2 are given. So by definition, this first moment is equal to 1, second moment is equal to 16, third moment about 2 is equal to minus. As we have relations, what we need in this case, so that the mean is 3, the variance is 15, and M3 is minus 86. What is M3? M3 is third moment about mean. Further, also show that the first three moments about origin, they are 3, 24, and 76. Okay, first of all, we must know what is given. This is given. First moment about 2 is given. First, second moment about 2 is given. Third moment about 2 is given. And they are denoted by M1 prime, M2 prime, M3 prime. And we have relations of the moments about mean. These prime moments. First moment about mean is always 0. Second moment about mean is in this with this relation. M2 prime is 16. M1 prime is 1. So 1 square, 16 minus 1 square, we have 15. M3 with this relation, M3 prime is given minus 40. M2 prime is 16, M1 prime is 1. Putting the values and simplifying, we get minus 86. And M2 is directly the value of the variance by definition. Now we expand this first moment about 2. Just expand this summation. We have power 1 of the deviations, just 2 terms we have with brackets. Apply sigma to both the terms. Apply sigma to both the terms. First one is xi, second one is 2, which is a constant. So when sigma is applied to a constant, it becomes n time, and dividing by n, we just so without this term, accept this one, shift all others to right hand side. Right hand side. So we have 3 on the right. What is 1 over n sigma xi? That is just the mean value. And also that is the mean value, and also the about 0. Similarly, expand the square of of the second moment about origin. This about 2. This is given. Now expand this square, apply sigma to all the three terms and dividing by n. Expanding the square, we have these three terms. Apply sigma and dividing by n. Apply sigma and dividing by n. Constant term remains the same, because when sigma is applied to a constant, it becomes n time, but at the same time we are dividing by n, so n is cancelled with n. Only we have constant. This term just we have calculated in above from here. This term is putting this value, but this term together with n, this term together with n is equal to 3. So putting the value, putting 3 and simplifying with rest of the terms, we have 24 on the right hand side, and on the left hand side we have 1 over n sigma xi square, the second moment about origin. Similarly, expand the cube and putting the values which are available. Sigma x over n is given just above, we have calculated, which is equal to 24, and sigma xi over n, which is equal to 3. All these values except first term, which becomes this one. This one becomes the third moment about origin. Shifting all the rest of the terms to the right hand side and simplifying, we get, which is similarly first 4 moments about a value 1.5. In previous example, this value is 2. Now in this case, this value is 1.5. And the first 4 moments are given. Similarly, in the same way, find the first 4 moments. How we proceed? We will expand the powers of the deviation from 1.5. In this case, about the value 1.5. This means the deviations are taken from 1.5 and different powers are used in first four moments. In first moment, power 1 is used, second moment, power 2 is used, and similarly up to fourth moment. Expand all these powers, apply sigma and dividing by n to each term. We will get one by one all the moments about origin, first 4 moments about the origin. As in this example, first four moments about x equal to 2 are given. First, we convert these moments about the mean. Here we have converted. Remember, first moment about mean is 0. First one is automatically 0, and rest of the two by putting the values. Okay. In this way, we will get first four moments about mean using the relation. And to find out the moments about origin, we have to expand the powers of the deviations from 2. And by expanding, we will apply sigma and dividing by n. In this, we don't use frequency. We are not given a frequency here. Just we need to calculate sigma xi over n, sigma xi power 2 over n, sigma xi power 3 over n. And similarly in this case. Okay. Yes, in what is available, what is given in our case. First of all, express your given data. We are given the first four moments like this, in which the deviations are taken with value 2. And we are given first four moments in this way. 1, 2.5, 5.5, and 16. Then proceed further, as we did in previous examples. So this was the dealing with the moments. Now, what is skewness? Skewness is an opposite word of the symmetry. Symmetry means a distribution is symmetric when the frequency curve is like this. What we have in this symmetry, a very big advantage we have in this case. We have mean, mode, and median at the same point in the center against the higher on x-axis. At this point, we have all the three values of mean, mode, and median when the distribution is symmetric. Okay, when the distribution is not symmetric, it is skewed, either of this shape or of this shape. This first one is called positively skewed, and this one is called negatively skewed. To recognize this positively skewed is that when mode is less than median, then definitely the distribution is positively skewed, or mode is less than mean, then all these three values will not be at the same point. We have mean value on the right hand side, mode against the highest peak, and median in between these two values. Values are on x-axis, so definitely x-axis on the left hand side we have lesser values, and on the right hand side we have larger values. So when mode is less than median, or mode is less than mean, or median is less than mean, any one of the three clue we have, we will say that the distribution is positively skewed. In case of negatively skewed, these measures are reversed. Mean value becomes the least value and mode becomes the largest value among these three, and median remain in between these two. So what we have actually in this case, mean is less than median, or mean is less than mode, or median is less than mode. We say that the distribution is negatively skewed. So this is a one way to calculate the skewness using mean, mode, median. But sometimes this information is not available, so we will try alternative formula to calculate the skewness. This one with the help of mean and mode, and also with the help of quartile, we can find the skewness. Skewness, or the coefficient of skewness. This is the same thing. Coefficient of skewness. No need to mention here the quartile coefficient. Just we can say the coefficient of skewness with an alternative formula. But how do we decide? About the skewness. This coefficient of skewness is usually denoted by B1. So when this value of B1 is zero, when this measure is equal to 0, distribution is symmetrical. Distribution is symmetrical. And B1, so we should write here a general case for all. Just we will say also we have an other formula for coefficient of skewness using moments. This expression is called moment ratio. In the numerator we have third moment about mean, and in the denominator we have second moment about mean. So this moment ratio also provides us the coefficient of skewness. Okay, now we decide. If this B1 is this B1 is 0, we say that is symmetrical. Okay. If B1 is greater than 0, that means we say that distribution is positively, and if B1 is less than 0 means negative, that then the distribution is negatively skewed. Drawing, the can say that the distribution is either symmetrical, positively skewed, or negatively skewed. Okay. Process is a measure to calculate the peakness of the distribution. Sometimes we have a frequency curve which is with the high peak, extraordinary high peak, and sometimes it is flat, and sometimes it is in between, not so flat and not so flat and not so high. It is called normal. Certain names for these distributions with extraordinary high peak. This is called leptokurtic, and this normal is called either the normal or mesokurtic, and flat curve is named as platykurtic. If you could not remember, just mention leptokurtic peak and platykurtic curve and mesokurtic as normal. But how can we calculate? One of the formula is with the help of the moments using this moment ratio. This in this moment ratio we have used, and in the second moment about the mean M2, the square of the second moment about mean. So if fourth moment is 6 and second moment is 1.5, putting in this formula, as we have a value 2, this will show that the curve is platykurtic. with this criteria. If this coefficient of kurtosis is equal to 3, the curve is normal. For leptokurtic, value of B2 is, and for mesokurtic, value of V2 is less than 3. Rephrase this statement. B equal to 3 showing the curve B or and B less than 3, showing the curve to be less than 3. Platykurtic or a flat curve. Value of B2 greater than 3. Value of B2 greater than 3, showing curve to be leptokurtic or with the high peak. And also we have some alternative formula with the help of quartile deviation and percentiles. Where quartile deviation is Q3 minus Q1 divided by 2. So let we go through these examples. Our fourth moment about mean is 243. Standard deviation, and also the distribution is symmetrical. Distribution is symmetrical. So what would be the value? One thing, the distribution is symmetrical. Remember, in all these cases, when we discuss the kurtosis, the distribution is normal. normal, or the distribution is, all the three distributions are symmetrical. So look at this statement. We are given fourth moment about the mean for a symmetrical distribution. What would be the value of standard deviation for the distribution to be normal? Normal means the value of B2 is case. So after information, this is given. And what is the formula for B2? This is the formula for B2. And this is equal to 3, and this is given. We need the distribution to be normal. Normal means mesocolonic. So the value of B2 must be equal to 3. So equating B2 equal to 3 and also the value of M4 and simplify for M2 square. Remember, M is the variance. So in this way, we get the value of the variance, which is equal to 9. By taking positive square root of this value, we get the standard deviation. Hence, for a symmetrical distribution, standard deviation must be equal to 3 for the distribution to be normal. Already it is symmetrical, but for normality, the standard deviation must be equal to 3. Similarly, try this example also. So in previous examples, whenever we are given 4 moments either about first we calculate, we convert them in terms of mean, and then using moment ratios, we can decide about the skewness and curve. Also, we have another exercise to go through these this exercise. Quartiles are given. Median and 2 quartiles means median is also a quartile. It is, this one is Q1 and this one is Q3. So using quartile formula, find the skewness. Second part is simple. As mean is less than the mode, this means mean is on the left hand side of the mode. So the distribution is negatively skewed. In third case, mean is greater than median, means mean is on the right hand side of the median. So the distribution is positively skewed. In this case, moments about a value 16 are given. What about the skewness? Just find the third moment about the mean, because in coefficient of skewness, to the formula. This is the formula of coefficient using moments. In the numerator, we have used the third moment about, and in the denominator, second moment about is used. Remember, second moment about mean is the variance, and variance is always positive. This means here this ratio is decided either is 0 or negative or positive just on the basis of M3. M3 is 0, this distribution is symmetrical. If M3 is negative, the distribution is negatively skewed. If M3 is positive, this distribution will be positive. So just on the basis of M3, we will decide about the skewness, coefficient of skewness. So first of all, no need to calculate all other moments. Just calculate from here the third moment about mean, just using the relation. Then decide whether the distribution is positively skewed or negatively skewed. In second exercise, the second moment about the mean of two distribution separately is given, and third moment is also given. So which of the distribution is symmetric, positively skewed and negatively skewed? Separately calculate the coefficients for both the distributions. Easily we can decide about the skewness. Similarly, try this exercise just on the basis of mean and mode. Mean is greater than mode. Mean is on the right hand side of the mode is against the highest peak, and mean is on the right side of it. Is in this case. Similarly, check others, and also finally this one. Try these exercises from the book. Remember, my dear students, we have 5 chapters of this book mentioned very early in my first lecture. We have completed first 5 chapters of this book. Next we will start, inshallah, our next chapter of probability. You have to submit this assignment within a week. Either you do it manually, or you can also use the Excel sheet for the Excel. Easily you can calculate these measures using Excel sheet. Otherwise, manually. One more thing, you can also generate these 100 values using Excel sheet. Not necessary to use the same, generate by your own. So if you need to generate them from Excel, this is the command. Range is from 100 to 500. You will get a single value in first box. Drag it downward up to 100. You will get ranging from 100 to 500. Then construct a frequency distribution. On the but the is 300 and maximum is whatever it is in this case. And also calculate rest of the measures mentioned here. You have to first submit to your CR, and CR will make a folder. And the weightage of this assignment is 5 marks. If we have some other assignments, we will reduce its weightage. Today we have 28 attendees. I am downloading their attendance. Okay, that's enough for today. Inshallah, see you next time.